Okay, so this video is for my geometry class. This is a 6.6 through 6.9 review for your test. Remember, for a great review, you should watch both videos just to refresh yourself on the first half of the chapter. Okay, so if you remember, 6.6 was about trapezoids and rhombuses. So here we go. We have a mid-segment problem. Okay, so notice EF is connected with midpoints E and F. Notice the congruent sides. So it is a mid-segment. There's a theorem that says that the mid-segment EF is equal to half the sum of the bases. And the bases in a trapezoid are the parallel sides, AD and BC. So we will add them together because it's half the sum. So EF is x equals 1/2 of AD is x minus 5, and BC is 2x minus 4. So I will simplify inside the parentheses. So x equals 1/2 times x and 2x is 3x, negative 5 and negative 4 is negative 9. And now instead of distributing the 1/2, I'm going to get rid of the 1/2 by multiplying both sides by 2. Again, just to alleviate fractions. So 2x equals, the 1/2 and the 2 cancel, equals 3x minus 9. I will subtract 3x from both sides. Negative x equals negative 9. And I will divide by negative 1. And I get an x value of 9. And they want to find the lengths of each of the segments with variable expressions. So to find AD, I will plug 9 in. 9 minus 5 is 4. To find EF, it is simply just 9. And to find BC, 2 times 9 is 18 minus 4 is 14. And if you look here, the mid-segment EF should be half the sum of AD and BC. 4 and 14 is 18. Half of 18 is 9. So you know you're right. Trapezoid mid-segment theorem. Okay. Next, here we have a rhombus. Okay, and we're taking a look. It says find the value of the variables. All right. So first, in this rhombus, remember this diagonal right here. I'm sorry, not a rhombus. Not a rhombus. A kite. A kite. Pardon me. Okay. Pardon me from before. This is about trapezoids and kites. Part of a kite is the fact that two pairs of consecutive sides are the same. So these single marked ones and these double marked ones. Now notice this diagonal, what it does is it creates two congruent triangles. Remember, the diagonal is congruent to itself, so they're congruent triangles by side, side, side. And that means that this angle is corresponding with that angle. They are congruent. So 3x plus 5 equals 4x minus 30. 3x plus 5 equals 4x minus 30. And we can solve this by subtracting 3x. 5 equals x minus 30 and adding 30. And we get 35 is equal to x. Okay? And that's the value of x here. And now we're in charge of finding the value of y. Now if you look further, okay, this diagonal, it bisects opposite angles. So these two angles are the same. And then these two angles. But notice not y and 2y minus 20 are the same. That's not true. However, look what I can do. I can bring y down here. So this angle is y. And now if I focus in blue on this triangle, x is 35. So what is this angle right there? Well, it's 4 times 35 minus 30. 4 times 35 is 140. 140 minus 130 is 110. That's a 110 degree angle. These two angles involve y. Let's use the triangle angle sum theorem. Y plus 2y minus 20 plus 110 equals 180. Then we can solve it this way. Y and 2y is 3y, negative 20, and 110 is positive 90. Subtract 90 from both sides. 3y equals 90, and divide by 3. And y is 30. And there you go. And there's the value of x and y in this kite. Okay, next problem here. So that was 6.6. Now we're going into 6.7. Here we go. Here's these biggies. We need to graph this quadrilateral and to determine what is the most precise name. So the first thing I will do is graph. Okay. So let me go. These are all positive, so I'll just go in the L-shaped positive coordinate, positive quadrant. 3, 5. There's A. 7, 4, 5, 6, 7, 6. There's B. 6, 2. There's C. And 2, 1. There's D. Okay, and there's the picture. Looks like a parallelogram, maybe a rhombus. I don't think it's a rectangle, okay? But the proof is in the work. First, find the slopes. Slope of AB equals B minus A, 6 minus 5 over 7 minus 3. That is 1 over 4. Slope of BC, C minus B, 2 minus 6 over 6 minus 7. Negative 4 over negative 1, that is 4. Now look, this is tricky. 1/4 and 4 are reciprocals, but they're not opposite reciprocals. So right now, no right angles, okay? Slope of CD. D minus C, 1 minus 2, 2 minus 6. Negative 1 over negative 4 is 1/4. Boom! A pair of opposite parallel sides. And now the slope of DA. That's A minus D. 5 minus 1 over 3 minus 2. And that is 4 over 1, which is 4. And again, a pair of parallel sides. So this has 2 pairs parallel sides. So right now we are a parallelogram, right? There are no right angles because these are not opposite reciprocals. So we're not a rectangle, we're not a square. We could still be a rhombus, and that's what we need to check for. Now, since we are a parallelogram, opposite sides are congruent, but to see if we're a rhombus, we need to see if 2 sides next to each other are congruent. And let's go with AB and BC. So to find AB, I'll use the slope formula. X's are 7 minus 3 squared plus 6 minus 5 squared. And this is the distance formula to find length, right? So I use the slope formula, the x's and y's, just plug them in here. This is 4 squared, which is 16. This is 1 squared, which is 1. That is the square root of 17. And then to find BC, I'll use again the slope formula. 6 minus 7, that's a 6. I'll just rewrite it. 6 minus 7 squared plus 2 minus 6 squared. That's negative 1 squared, which is 1. That's negative 4 squared, which is 16. And again, this is the square root of 17. And because these 2 sides next to each other are the same, this means you have 4 congruent sides. And if you have 4 congruent sides, you are a rhombus. There you go. Okay, so remember, start with slopes first. And then depending on how many parallel sides you have, that determines what you need to find the length of. Kite, all 4 sides. No parallel sides. So find the length of all 4 sides. Trapezoid, 1 pair of parallel sides. Find the lengths of the legs and see if it's an isosceles trapezoid. And then a parallelogram, find if both pairs of opposite sides are parallel, then you need to just find 2 sides next to each other to determine if all 4 sides are congruent. Okay, here we go. A placement picture. Here we go. So this rhombus is centered at the origin. T to Z is 2T, so that is 2T. And S to W is 2R. So I'm going to do it down below. So this is 2R. Okay? And the question is, let's label the coordinates. All right? So S, T, W, and Z. So what is S? Well, S goes off to the left. Well, if this is 2R, then off to the left is going to be one of those R's, negative R. And then you do not go up or down, so it's 0. T, you do not go left or right, so you're at 0. But then you go up, and you go up half of this length. Well, this length is 2T. Half of 2T is 1T. W, you go out the same way you went out for S. So you're going to go out R, and you're in the positive direction. And again, you don't go up or down, so you're 0. And Z. Z, we're not going left or right, so our x-coordinate is 0, and we're going down. Half of this length, half of 2T, is T, but you're going down, so it's negative T. And there are the sets of coordinates for this rhombus. Okay. And then the last one here. This is one of those proofs. Here we go. So here's the setup. You have a triangle, PQR. It tells you that PQ and QR are congruent. That's why it's an isosceles triangle. So, so this side is congruent to this side. M is the midpoint of PQ, N is the midpoint of RQ. So M and N are midpoints. And we're trying to prove that the medians drawn to the congruent sides on an isosceles triangle are congruent. That would be these two sides, PN to and RM. We're trying to prove those two sides congruent. All right. So this is a two-step proof. First, we have to find M and N's coordinates. M and N are midpoints. Find M and N using the midpoint formula. So M is going to be negative 2a plus 0 over 2, and then 0 plus 2b. 0 plus 2b over 2. And that would be negative 2a over 2, which is negative a. That would be 2b over 2, which is b. So there's M's coordinates, negative ab. And then we'll find N's coordinates. So we use R and Q. Let's go 2a over 0 divided by 2, and 0 plus 2b divided by 2. So again, it's 2a plus 0. It's the x's added together and then the y's. 2a divided by 2 is a. 2b divided by 2 is b. And there's N's coordinates. So that's step one. And now that we have the coordinates of our endpoints, our midpoints, now we find the lengths of the sides. So step 2, let's find PN and RM. And these are lengths, so we'll use the distance formula. PN, so we're going to go, let's go N minus P. So that's going to be A minus negative 2A squared plus B minus 0 squared, all inside of a square root. This becomes plus plus. This is 3a. When you square 3a, you square 3, 9, and you square a squared. Plus, this is b, and b squared is just b squared. And that's done. Remember, you don't touch that. You cannot distribute this square root over addition. And then we'll do Rm in the same way. And for Rm, I will take R minus M's coordinates. So we'll go R, 2a minus M, negative a squared, plus R, 0 minus M, b squared. Here we have plus plus. This is 3a squared. 3a squared is 9a squared, plus negative b squared, and negative b squared is positive b squared. And there you go. They are the same. So we have shown that Pn is congruent to Rm. And that's what we wanted to prove. Okay. So feel comfortable working with these variable coordinates. Not a big deal. Okay, so I think this is a good review. So again, this was shorter, so I would try the other one just to make sure you know the whole chapter, and maybe try some problems from the notes. And that would be good. All right, thanks for watching. We'll see you later.